Hello students, let us start the next practical, that is develop a ladder diagram for adder and subtractor using PLC. Okay, so in this we are going to see half adder, half subtractor, full adder and full subtractor. Okay, so here is the diagram and truth table for the half adder. As you can see, A and B are the inputs. Okay, when they are given to the XOR gate, the output is sum. The output will give you sum, and AND gate gives you the carry. Inputs to the AND gate are also A and B. Now let us see the truth table. So in the truth table, the inputs are A and B, and we can make four combinations of A and B, 0, 0, 0, 1, 1, 0 and 1, 1. So for the inputs 0, 0, sum is 0, carry is 0. For inputs 0 and 1, sum is 1, carry is 0. For inputs 1 and 0, sum is 1, carry is 0. And for inputs 1 and 1, sum is 0 and carry is 1. Okay, so this is the truth table. Now let us draw the PLC ladder diagram on the simulator. Okay, so in the first rung, we have to take the XOR gate. The XOR gate output will give you sum, and in the second rung, we will draw the AND gate. It will give you the carry. Okay, so first of all, XOR gate. So take one open switch, then close switch, and now we have to add the parallel branch. For that, click on plus, again click on plus. Okay, now again close switch, then open switch, close switch, then open switch, and output device, lamp or LED. Now, so this is the XOR gate for getting the sum. Next, we will take AND gate. So AND gate includes two open switches connected in series, okay, and the output device here. Place it here, okay. The next task is giving the labels or tags. So first input is A. First input is A. Submit. Second is B. Submit. Again A. Submit. B. Submit. And the output is sum. Since it is XOR gate, its output is sum of the half adder. Next, A. Submit. Now it is the input of AND gate. B. Submit, and the output is carry. So in this way our ladder is complete for the half adder. Now let us compile it. So click on compile. Okay, compiled successfully. Now run. Now we have to check the all possibilities in the truth table, that is 0, 0, 0, 1, 1, 0 and 1, 1. A and B are 0. Initially A is 0, B is 0. So at that time, see the truth table, sum should be 0 and carry should be 0. Okay. Next, A is 0, B is 1. Toggle it. B is 1. Then sum should be 1, carry should be 0. Next, third case, A is 1, A is 1, toggle it. B is 0. At that time, sum should be 1, is it? And carry should be 0. Next case, A is 1, B is 1. In this case, sum should be 0 and carry should be 1. So in this way, we have successfully created the ladder diagram for half adder. Okay. Next, the next is full adder. So full adder is having three inputs and two outputs. The three inputs are A, B, and carry in, and the two outputs are sum and carry. So see here, A and B are inputs for the first XOR gate. Whatever is the output of first XOR gate is input for second XOR gate. Then the second input to the XOR gate is C in, and the total output of second XOR gate is sum. Next, for the carry purpose, we have to draw the AND gate. So for the first AND gate, inputs are A and B. Okay, from here. Then for the second AND gate, the inputs are A XOR B. So that is obtained from here. A XOR B. And the second input is C in. Okay. Next. The outputs of these two AND gates are OR together to get the carry out or total carry. Okay. So this is the truth table of full adder or diagram of full adder where two XOR gates, two AND gates and one OR gate is used. Now let us check the truth table for A, B and carry in. 0, 0, 0 gives you sum 0, carry 0. For 0, 0, 1, sum 1, carry 0. For 0, 1, 0, sum 1, carry 0. For 0, 1, 1, sum 0, carry 1. For 1, 0, 0, sum 1, carry 0. For 1, 0, 1, sum 0, carry 1. For 110 sum 0 carry 1, and for 111 sum is 1 and carry is also 1. Now let us take the next example, that is half subtractor. So there is a little difference between half adder and half subtractor, that is one of the input of the XOR is inverted while creating the borrow. In case of subtractor, we will call it as borrow. And difference, see how the difference is taken. The XOR get will give you the difference, and the A input is inverted, okay, and B is taken as it is, so it will give you the borrow. So see how it is calculated. Difference is equal to A XOR B, and borrow is equal to A naught or A bar into B. A bar and B. Okay. So truth table is like this. A and B are inputs and difference and borrow are the outputs. So for 0, 0 input, difference is 0, borrow is 0. For 0, 1, difference is 1, borrow is 1. For 1, 0, difference is 1, borrow is 0. And for 1, 1 inputs, difference is 0 and borrow is also 0. Now let us implement this using the simulator. Okay. Refresh this and draw the new diagram. Now we want to draw for the half subtractor. So for the half subtractor, add one rung. Okay. XOR for the XOR gate, one open switch, close switch in series with that. Take a parallel branch, click on plus, click on plus to complete the parallel branch. Again in the next, close switch, open switch, output device. Okay, so this rung is for the borrow. Now we will take the next rung for sorry, the first rung is for the difference. Now we will take the second rung for the borrow. So in that we have inverted A. Okay, so A is taken as the close switch and B is open switch. So that will give you A naught into B and then one output device. Okay, now our design is complete. Just tag it, give the labels, tag A, submit, tag B, submit, Again tag A submit, tag B submit. Okay, and this is the difference. You can call it as D for difference. D submit. Now these inputs are nothing but A and B. Just tag them as A submit, B submit, and this is borrow. Let us call it as B or BO. Okay, now our ladder diagram is complete. Let us compile it. So it is compiled successfully. Now let us run it and check for the inputs 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so in this case, A is 1, B is 0. So let us make it first 0 by toggling it. It is 0, 0, 0. For the 0, 0, the what should be the output? So now let us see what is 0, 0. 0 means as it is. Whenever it is as it is, then the output should be 0, 0. For 0, 1, for 0, 1, both should be 1, 1. Okay, difference is 1, borrow is also 1. For 1, 1, difference is 0, borrow is 0. Okay, and for 0, 1, difference is 1 and borrow is 0. So this is about the truth table of the half subtractor. Now let us see the full subtractor. Okay, in the full subtractor, what is taken? Two XOR gates are there for the difference. Two AND gates are there, and for the AND gate, one input is inverted, and whatever is the output of OR gate is taken or ORed together. Okay, so D is the difference, B is the borrow here. Now let us check the truth table. So for this inputs are A, B and borrow in, and the outputs are difference and borrow out. So for 0, 0, 0, D is 0, difference is 0, borrow is 0. For 0, 0, 1, difference is 1, borrow is 1. For 0, 1, 0, difference is 1, borrow is also 1. For 0, 1, 1, difference is 0, borrow is 1. For 1, 0, 0, difference is 1, borrow is 0. For 101, difference is 0, borrow is 0. For 110, difference is 0, borrow is 0. And when three inputs are same, that is A is 1, B is 1 and borrow in is 1, then difference is 1 and borrow is also 1. So from the above examples, you can draw the ladder diagram for this also.